Alright, so let's take a look at the last part of section 3.5. So we started talking about slope-intercept form. Someone remind me what slope-intercept form is? Y equals mx plus b.
There you go.
And the m, what does that represent again? Slope. And the b? That's your y-intercept. What does that mean? Y-intercept is where what happens? Yeah?
The line crosses the y-axis.
Yeah, exactly. It's where the line crosses the y-axis. Yeah. Do all lines cross the y-axis? No? Could you give me an example of a line that doesn't?
Horizontal. Undefined.
Well, you said horizontal.
I mean vertical.
Vertical, yeah. If you had a vertical line, it might not cross the y-axis, right? Here's your y-axis. Here's a vertical line. Never crosses it. Every other line will. Whether it's horizontal or slanted, it will. But vertical might not. All right, so what we're going to look at is graphing equations in y equals mx plus b using the slope and the intercept. We graphed earlier in the week using intercepts. Remember when you plug in 0 for x and you solve, and then 0 for y and you solve? Well, that's one way to graph. That was standard form. This is another way, slope-intercept form. So, okay, on your guided notes, first step, if you want to graph something in y equals mx plus b form, first it has to be written in y equals mx plus b. So we did one in the warm-up where we had to move stuff to the other side to get the y alone.
You guys, we didn't want to say, okay, we have to get it in y equals mx plus b form. What are we trying to do with y? What's the goal? We're trying to get it in that form. Get y
By itself.
by itself. Right? So to get it in slope-intercept form, you have to have y by itself.
Once you have that, the first thing you want to do is put a dot on the y-intercept. Okay, so somewhere on the y-axis, that number is going to tell you where. You're going to put a dot. So put a dot on the y-axis. That's your y-intercept.
How do you know which number is the y-intercept? There's a couple different ways, but what's one way? How do you know what the y-intercept is in your equation? Anybody know?
It's after the slope.
Yeah, it's going to be after the x, right? Another way you can think of it as, it's going to have no letter attached to it. It's just going to be a number. And make sure you guys pay, we talked about yesterday, make sure you pay attention to the sign to the left, whether it's positive or negative. Right? So like Chris said, it's either going to be after the x, a number with x, or another way to think of it is, it's going to have no variable attached. It'll just be a regular number, a constant.
Is there any question on that part? So at this step, you might have a graph, something like this. You're going to have a dot, like right there. Okay, so that's all you have after step 2. Now, to graph a line, we need another point. Okay. What else do you think what am I going to use now? I used my y-intercept. How am I going to get another point? What haven't I used yet? Yep. I haven't used the slope. So the slope is going to give us like directions. From this point, it's going to tell us which way to go to get another point. So from the y-intercept, okay, from the dot that you just made, which is why it's important to get this dot right, because if you get it wrong, then you're starting at the wrong spot. So from your y-intercept, we're going to use the slope to find another point on the line. Now, you might have an equation like this. And you might say, well, wait a minute, the slope isn't a fraction, it's just a 2. How can you make 2 a fraction? You can always put it over what number, Matt?
1.
You can always put it over 1. Now, does anybody remember the two words that we used to describe slope? It began with R. Yep.
Rise over run.
Rise over run. So in this case, rise, run. So the 2 and the 1, they're directions. So rise, think about rise. Like if you let a balloon go, it rises up, right? Up. Rise is up or down. So rise is in the top, run is in the bottom. So there's only 2 ways we're going to move, right? We're either going, oh yeah, whole numbers over 1. We just said that. You're either going to have a negative slope or a positive slope. Okay? You're going to have one of those 2 situations. So negative slope, you go down and to the right. Right? Negative slope, you go down and to the right. Positive slope, you go up and to the right. So negative slope, down and to the right. Positive slope, up and to the right. So you're always going to the right, right? That's always happening. So your run, the number in the bottom, is always how many to the right you go. The number in the top, well, it could be 2 ways. It could either be down or it could be up. How do you know? If there's a negative with that number in the top, it's down. If there's no negative with the number, it's up. So any question on the direction to move? So it's either up and right or down and right. Those are the only 2 options you have. Okay, so let's look at this one. Are they all rearranged, Mr. Roy? Do we have one that's already in the form?
I don't.
Okay, so this is a harder one to start with because you don't have y by itself, right? You might have a problem where y is already alone. This one, it's not. Okay, so what's preventing y from being alone here? Yeah? The 3, and what else?
6x.
The 6x. So this is pretty much the hardest kind of problem you can have because you have everything on the wrong side. Okay, you don't just have one thing. You get the 3 and the 6x. So the way we have to fix it is we want to move the stuff that's furthest away from the y first. Right? The 6x is further away from the y than the 3. Right? We're going to deal with the 3 last. Think of the y as like protecting the 3. Right? The 3 is right next to the y, so the y is hanging on to it. It can protect it. The 6x is further away. It's kind of hanging out by itself. The y is too far away to protect it. So that's the first thing we can get rid of. Is this a positive or a negative 6x? Donovan?
Positive.
It's a positive. So how would we move positive 6x to the other side? You said?
Minus 6x.
Exactly. We're going to minus 6x and minus 6x. When you do 6x minus 6x, that's gone. What's on the left side now? Y still isn't alone, but it's better. Matt?
Negative 12 minus 6x.
Left side.
Oh, left side? Just the 3y.
Just the 3y. Now, can anybody tell me how to write what's on the other side and we want to put it in the correct order? Remember, we're trying to get y equals mx plus b. So we kind of want to follow that pattern. Yep.
Would you like divide? Like 3y?
Not yet. We still have to take care of how to write this.
Negative 6 minus 12.
Negative 6 x. And then what else?
Minus 12.
Minus 12. All right. So we always want to put the term with the x first. The term with the x was a negative. The 12 was a negative. They're both negative. So when we write it, both of them still have negatives in front of them. Okay? If the 12 didn't have a negative in front of it, I would have put a plus 12 here, because it would have been a positive. Okay? But they were both negative. Any questions on that first step? Yep.
So basically, like when you like do minus 6x, you just like you can just like put it right in front of like the 12. Like that.
Yep. You put it right in front. The number with the x should always be right after the equal sign. Yep. If you did negative 12 minus 6x, you're not wrong. Like that's still mathematically correct, but that's not the order we're looking for. Okay. All right. Do we have y by itself now?
No.
No. We still have one more thing we got to get rid of. It's right next to the y, but now we can finally get rid of it. Yep. We're going to have to divide by 3. Here, here, and here. That's the trick some people forget. They don't do it in every spot. When you do division, you have to do it in every spot. So, Ryan, what's 3 divided by 3?
1.
1. Perfect. So that's gone. So now we just have y equals. And now we have negative 6 divided by 3. I think we can simplify that. Nicole, what's negative 6 divided by 3? Negative 2. Now all we did was reduce this. The x is still right there though. So negative 6 divided by 3 is negative 2 with the x. Minus, and then 12 divided by 3. How about Joe?
Negative 4.
Negative 4. Perfect. Okay, so that one was tough because it had everything on the wrong side. So we had to do all that work just to get it in the right
Order.
yeah, just to get it in the right order. All right, now let's graph it. All right, so the first step, let's go back. Make sure your equation is y equals mx plus b. Yeah, we did all that. Graph your y-intercept. Okay. Looking at that, what's my y-intercept? Yeah?
Negative 4.
Negative 4. It's right there. It's the number that doesn't have an x. So I'm going to go down 4 and put a dot. Now, that's not enough information to draw a line. I need another dot. That's where step 3 comes in. From the point we just did, use the slope to get another point. So use the slope. Okay, let's look at the slope. The slope, I'm just going to put it off to the side here. Slope is negative 2. Well, we usually want the slope as a fraction. So how can I write negative 2 as a fraction? Matt?
Negative 2 over 1.
Yep, put it over 1. The top number, with the two words that begin with R to describe slope, what's the top number?
Rise and run.
Rise. And what's the bottom number?
Run.
Run. All right. The rise is negative 2. So what does that mean I'm going to do from this point? Which way do I move? Donovan?
Down to
Down 2. And then the run is 1.
yes.
We always move which way for the run?
Right.
Right. Down 2, right 1. Now, if you want, you could do it again. Down 2, right 1. I mean, you can do it as many times as you want. Down 2, right 1. That's enough. So you just do it. I do it a couple times, and now I'll draw my line. All right, so let's see. Oops. Let me actually make it look kind of straight. Wow. That's good enough. It's not perfect, but pretty good. So there's your line. All right. You know what? I'm going to actually, because they're asking us for the x-intercept, I tried to draw it straight, but it's not it's not letting me. Okay, there you go. I can use that. All right, so probably about like that. Let's see how that looks. My board is having technical difficulties. Okay, I think that's pretty good. All right, so the y-intercept is -4. They're also asking me for the x-intercept. Where does it look like the x-intercept is? It's pretty close to what number? I mean, it's not exact, but I tried to draw it as straight as I could. Yeah. Yeah, -2. Right here. In fact, you could figure out that it's there if you just kept going the other way with your dots. I said we don't normally go to the left. You can. Up 2, left 1, up 2, left 1. There you go. And you could keep going. Up 2, left 1, up 2, left 1. You don't need to go that many times. But there's your x-intercept right there. -2. So doing it from a graph means you have to draw it pretty straight. Right? If your graph is a little crooked, it's not going to come out very nice. Also on the test, if Mr. Roy and I are having you do it from a graph, it's going to cross at a nice number. It's not going to cross at like -2.6 or something. That's too hard to tell from a graph. Right? It'll be a nice number that's not a fraction. Okay. Any questions on that one? There's kind of a lot of steps there. Okay, getting all that stuff. All right, let's try. Let's try this one. Okay, it says graph the linear function. Identify the x-intercept. 4x minus 2y equals 2. Now, that's an equation that's in standard form, right? That's not slope-intercept. So, if these were the directions on the test, and it said graph this equation, I would do this the way we learned on Monday.
Like 0?
Yep. I would definitely just plug in a 0 for x, get the answer, plug in a 0 for y, and be done. That would be a lot faster, all right? Usually we want to use slope-intercept form when it's already something like that, right? But since we're practicing it, we'll go through it. It is good practice to get y by itself, even though it is going to take longer. All right. So what do I have to do first here to start to get this in slope-intercept form? Yep.
Subtract 4 from both sides? Or would you subtract 2 from both sides?
Subtract what?
2.
No, you always want to get rid of the thing that's further away from the y. Remember, think of the y as protecting what's on the same side. You can't protect things that are further away, so you got to get rid of the whole thing that's further away. So you mentioned part of it. Matt?
Subtract 4x.
Yeah. This is all one thing, 4x. So you subtract it and subtract it. Okay, Jake, what's on the left-hand side now?
Left-hand side is 2y equals 2.
Just on the left, Jake.
Just the left, but be careful. There's some. You said part of it was on the left.
2y.
A little bit more than that. 2y is part of it, but what's in front of it? Not sure. Anyone help him out? What's still there that we didn't do anything with this yet? Yeah. The sign, which is a negative sign. So this is all gone, but the negative 2y is still there. Now, on the other side, I have 2 minus 4x, the way I have it written right there. Is that the order that I wanted it?
No.
No. I want the term with the x first. So anyone think they can tell me how to put the right-hand side in the correct order? You said?
Negative 4x.
Right? Negative 4x.
Plus 2.
And then plus 2. How did you know plus 2? Like the last problem, I think it was a minus. It was a minus 12. How'd you know this was a plus?
Me?
Yeah.
Because there's no negative in the 2, it's just normal.
Yeah, exactly. There's no negative in front of the 2. So it's a positive 2. All right. So we didn't change any signs. The negative stayed with the 4, the positive stayed with the 2. All we did was we changed the order. And that's okay. All right, are we good now? Is this y equals mx plus b?
Yeah. No.
Yes.
Yes.
Some people say yes.
One more step. I think.
No. Oh, yeah.
Simplify.
Yeah, simplify.
Divide.
It's divide.
Divide.
Divide, yeah.
Divide.
What would you divide by?
Negative.
Negative 2. Where would you do it?
Under.
Every
fraction bar.
Everywhere.
Everywhere. Okay, I'm going to write it 3 separate times because I want you to remember to do it 3 separate times. Sometimes people put a big fraction bar and they put one number and they only do it once. They don't, for some reason, they don't do it to both. I think if you write it 3 times, you'll remember I got to do it 3 times. Negative 2 here, what happens? Ellie?
They cancel out and you get y.
And we
So
get
then
y.
it'll be y equals something.
Yep. Now my next number is going to be something with an x. I have negative 4 divided by negative 2. 2. Yep. So I've got my slope now. Still need my y-intercept. What's my y-intercept going to be? Negative 1. It's positive 2 divided by negative 2. Positive 2 divided by negative 2 is negative 1. Now we've got our equation in y equals mx plus b. Now again, in the time it took me to do that, I could have just done this problem the way we learned on Monday, and we would have been done. But there are going to be times, I think, coming up where we have to get y by itself, especially when we get into solving multiple equations at the same time. That's going to be one thing we have to do. Okay, so now we're ready to graph it. How do I graph it?
Bless you.
Vote. Nate, I haven't heard from you today. How do I graph it?
Don't you put a dot on negative 1?
And where am I? How do I get to negative 1?
You go down 1.
Yes. So,
The y-intercept.
okay, so we got our y-intercept. Brady, is that good? Can I make a line now?
Yeah.
Okay,
Yeah.
just make my line
Yeah.
like this?
No. Not anymore.
No, like this?
No.
No. Oh, maybe more like that. No. So I only got 1 point. I don't know which way to make my line yet. So what else do I use, Ellie?
2.
2? What's that? Oh, 2 over what?
2 over negative 2? Oh, 2 over 1.
2 over 1. Remember, if there's no fraction, you can put it over 1. It's the only number you can put it over if it doesn't have a number already. All right, so now it's like I've got directions. 2, 1.
So do you go over 2 and down 1?
Then you go 2 down over.
Rise over run.
It's rise over run.
Yeah.
So the 2 options are up and right or down and right. There's no other options. Which way is this one? Up and right. Up how many?
2.
Up 2. Right how many?
1.
1. Up 2, right 1. Where do I do that from?
0.
Right here?
Negative 2.
From negative 2. From the y-intercept. Up 2, right 1. And again, usually do it a couple times. That's good enough. Now, since I want us to find the x-intercept, I have to do this pretty exact. All right, so this one crosses in between 2 lines. All right. Now remember, I told you that if we have one, it's not going to be like a crazy number like 0.6 or 2.3 or something like that. It's going to be pretty simple to figure out. So it's either going to cross at a nice number or it's going to cross at a half. All right. So where does it look like this one crosses? at a nice number or in between two numbers? It's in between. So where does it cross here? A half. Yep. So your x-intercept is 0.5 or 1/2. Okay, again, even that could be a little tricky with a half. We're going to try to make it so it crosses at like a nice number. Yep.
If it was to be -2, we would go down and then -1, right?
So if it was -2?
Yeah.
Yep. So if I put this back, my y, let's say you had the same y-intercept, and if you said -2, down 2, right 1, down 2, right 1.
Remember, when your slope's negative, you only want to treat the top number as negative, not the bottom. You never want to go down and to the left, always down to the right. So you guys know, we talked about it yesterday, if it's a negative slope, it always drops down to the right. If you go down to the left, it's going to end up going up to the right, so it's going to be a positive slope. You don't want that.
Right, so that's how you do it. Okay, any question on that one? All right.
Bring me in, mistake.
What's that?
Bring me in. Sure. Alright, so guys, last one. This one, it's still slope. It's just written a little bit differently. A linear function f models a relationship in which the dependent variable, that since it's the y value. Alright? So we got the y, and then we got the x. The y, right? The y-axis. What direction does it go? Down or vertical, right? So up and down, right? Or think about slope, right? What do we call slope again?
Rise over run.
Rise over run, right? So the y is kind of like the rise. And we're giving it to you first, all right? Then we're giving you x second, which is the what? The run, left or right. So the way it's written is still going to be like the slope, right? You're going to put your y, or your dependent variable, over your x, or your independent variable. And that's going to be your slope, all right? So it tells us the y value increases 3 units. What does that mean? What number is that?
+3.
Positive 3, right? So I don't have to put a sign with it. I can just put 3 over. For every 1 unit, the dependent variable increases. Ellie?
So would it be 3 over 1?
3 over 1, right? So it says the x value is increasing. So it's positive. They're both positive. So this is your slope. You don't have to write this if you don't want to. But again, that's the slope. It's written in the problem, right? When I'm circling, so everything I circled is the information given about the slope, right? It's written out, but it's still going to be 3 over 1, right? The y, the up or down, over the x, the left or right. Rise over run. So this is my slope. Now, it says graph f when f of 0 equals 2. All right? So basically, guys, this is remember we said last week, a couple academic, before we had the double academic week, f of whatever means what? It could be f of 3, f of -100. That's just a fancy way of saying what? Does anybody remember? Okay, but think about it, right? We're using slope-intercept form, right?
Oh, why?
Exactly. This f of 0 could be f of whatever number. It still means y equals. That's just function notation, all right? We're using slope-intercept form. But this means the same thing as y equals 2. All right? So my y-coordinate is going to be 2. What's my x-coordinate going to be? What's my x-coordinate going to be?
0.
0. All right? So my y equals x is 0, y is 2. So to graph, we need two things. We have the slope, which we already figured out. And what else do we need to be able to graph it? Mary?
The y-intercept.
Y-intercept.
That's not the same problem we have.
Oh, you don't have that same one?
Ours just says also the y-intercept is 3.
Oh, the y-intercept is 3? Okay. Do you have, is it still this, 3 units for 1?
Yeah.
It's still 3 for 1, and it says the y-intercept is 3?
Yeah.
Okay. So we don't have to, so if it's written like this, guys, 0, 2, your y-intercept would be 2. Sometimes they may just give it to you. So in the problem that you guys are given, the y-intercept equals what, Mary?
3.
3. Sometimes, but if it's written like that, f of 0 equals 2, this 2 is your y-intercept. All right? So where am I going to start my graph? Somebody tell me. How about Nigeli? Where am I going to start my graph? Where do I always start? I mean, it's going to be a different number every time, but what? Again, we have two choices because we're doing slope-intercept form, right? We're either going to start at the slope, or we're either going to start at the y-intercept. Where are we going to start? Y-intercept, right? All right. So where's the y-intercept in this problem? 3. On which axis? So where do I go? Up 3. There's my first coordinate. All right. Always going to start the y on the y-axis, whatever number it is, whatever number the y-intercept is. All right. From there, Brittany, where am I going to go from there? So I've already used the y-intercept. What's the only thing left I have to use? All right. So the y-intercept, done now. There's nothing else more I can do with it. What's the only other thing I can use now? Remember, it's slope-intercept form. I already used the slope. I already used the y-intercept. What do I have left to use? What other number's up there? 3 over. And what is that? Is that the y-intercept or is that the slope? Slope. So from here, what does the slope tell me to do? Over 1, what direction? Left or right? Right. Good. Up 3, 1, 2, 3, right 1. I can do it again if I want. If you only put 2 dots, that's okay too. 1, 2, 3, over 1. There's my line. Let me get a thing here. Alright, so there's my line right there. So in this problem we already identified, what's my slope? What's my slope in this problem? Someone tell me. There's 3. I want to put it over 1. Just, I'm sorry, yes, 3. We can put 3. Slope is 3. Y-intercept is? So y-intercept in this problem. Guys, stay with me here. What's the y-intercept? 3. So again, that's just a different way of doing it, right? It's written out kind of like in function notation, all right? So again, it may just give you the y-intercept, or if it's written like this, just know this number right here, whatever the f equals, it's going to be your y-intercept. Either way works, all right? Let's just fix my graph.
I'm just fixing it because when you do your x-intercept,
Oh, my x-intercept, so I didn't really have to do that.
it would have put the little.
Alright, so for this one more thing. What's my x-intercept? Someone raise their hand and tell me what's my x-intercept. Gigi? Huh? -1, right? Where it crosses the x-axis. Y-intercept, where it crosses the y-axis. X-intercept, number it crosses on the x-axis. Alright? Good with this? All right. So, couple reminders. Homework. I think there's only like 3 problems that we did today. The back is mainly review of stuff we've done the last couple days. All right. Guys, reference sheet will be posted by tonight. I'm hoping it's going to be posted by like 1 o'clock this afternoon. So if you have something that later in the day you can print it off, you can do that. All right. Oops. Second test of the quarter, guys. This maybe have you guys at a double shop week. So it's only going to be the second test of the quarter on Friday. Progress reports also close on this Friday. So you'll have the test you got back on Monday from last academic week, and you'll have this test that will go on there. Any homework that we've done.